Okay, so here we go. So this worksheet here is essentially making sure you know how to convert, any function that you have down here into a power series using one of the memorized ones or the ones that you're working on memorizing. And eventually you will get them, because if you don't memorize them, you have to do it the long way, which is take all kinds of derivatives, plug in your values, write it out, find the rule, and it's very tedious, very tedious. So we're just going to do a couple of them just to make sure we get the idea, and some of them we already have in our notes a little bit. So we're going to go ahead and just take a look at, let's see, number 4. I'm trying to, sorry, I think I can fit this on here. Okay, so for question number 2, so sine of 3x. So all we're doing is we're trying to say, okay, what am I replacing what with? So I have the sine of 3x here. So I look at what the expansion is. So sine is our odd powers. And then this is the general rule, and this is the first 4 terms expanded, and then this is it written into summation. And so that's what you're looking to do, is expand the first few terms, write the general rule, and then put it into sigma notation. Okay, so number 2, so I'm going to do that. So all I'm doing is replacing x with 3x. So instead of x, it's going to be 3x. And then minus x cubed over 3 factorial, so that would be 3x cubed over 3 factorial, and then so on. So I'm going to go dot, dot, dot. That's plenty of terms. And then I'm going all the way over to the general rule. So now this one is negative 1 to the n. And instead of x, we have 3x. Oops. Hazards of using a pen. Okay, 2n plus 1 plus all over 2n plus 1 factorial. And I definitely do not have enough room, so let me get out a piece of paper here. There we go. Okay, and then I'm going to do a little bit of simplifying. Okay, so then I would have 3x minus 3 cubed, which is 27, x cubed over 3 factorial, and then negative 1 to the n. And then the 3 is just going to be 3 to the 2n plus 1, and then x to the 2n plus 1 over 2n plus 1 factorial. So something like that. Okay? Easy. And then for summation, this would just go into my summation form. And so just a reminder, because we haven't talked about this in quite a while, if I were to graph sine of 3x in radian mode and also graph, say, like the first 4 or 5 terms of this expansion, those graphs should look the same. And because we're doing Maclaurin, that would be centered around 0. So maybe if you look at x equals 5, it wouldn't look the same. But if we were around 0 and I were to graph this in my graphing calculator and graph the first, 3, 4, 5 terms, the graph should look the same because that's what we're trying to do, okay? So I think the front worksheet is pretty easy because we did a bunch of those examples yesterday, and then we just finished up the other one today. And that one's like, the one we just did was like number 6 and 7 on the worksheet. Okay, so it's the back side though, that's going to be a tricky little problem. So the upper bound, LaGrange error bound, all of that is not covered very well in our textbook. And so here are a few examples, not examples, but problems that I want you to do to practice a little further. So the first 4, I believe, are all error problems. And then the rest are just kind of, just weirdo little questions that I want you to do. So I do want to do at least one of these together to think about it. And then let you, struggle through the rest because they are tough. So good luck there, class. And hopefully Mr. Flores can help you with these. Okay, they're tough. I'm not going to lie to you, they're hard. Okay, so here we go. So let's do number 2. So find the 4th degree Maclaurin polynomial approximation for cosine of x where a is equal to 0, evaluate it at 1, and then find the Lagrange error bound. Okay, so you guys do the 4th degree polynomial approximations. That's when you do all your derivatives, plug your numbers in. Okay, so I'm going to turn my cute little face off here, though. Okay, so you guys do that part for me. Okay, so cosine of x. Okay, so 4th degree, is that 4 terms or to the degree of 4? Okay, to the degree of 4. And then does cosine start at x to the 0 or x to the 1st? X to the 0, so that'd be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. So that's one of the memorized ones. So when we do that, there is our 4th degree Maclaurin polynomial. So this is without having to do the derivatives because we are taking the time to memorizing it. And so this is my 4th degree polynomial. So it's exactly equal. I get it's approximating something, but that is my 4th degree polynomial. And so now what I want to do is I want to evaluate this at 1, so it was centered at 0. So I just now am noticing it said a equals 0, but meaning like we're centered at 0. So that should have been c equaling 0 there. So now we're going to evaluate this at 1. So I'm going to replace x with 1. So 1 squared and 2 factorial is 2. 1 to the 4th is 1. And then 4 factorial is 24. And some more arithmetic. So what do we have here? So 1/2, 11, 1/2 is 12, so 13. 13 over 24. Did I do that right? 1 minus 1/2 is 1/2. So it's 12 plus 1, which is 13, yeah. Okay, so here we go. Sorry. Now what do we need to do? So now we have to find the Lagrange error. Okay, so I was trying to do my arithmetic in my head, making sure I did that right. Okay, so the Lagrange error. So now I need to think about cosine. So between 0 and 1, so between where we're centered and where we're evaluating. So we are centered at 0, we're evaluating at 1. So I want to find the maximum for what cosine can be between 0 and 1. So I can graph it, right? I could graph it and look to see, okay, what is its maximum value there? Or I can just know that cosine cannot go above 1 or below -1. So if cosine can't go above or below -1, then I know that its error has to be less than or equal to 1. So this is just even terms. So I know that it goes 1 and then like 1 is being skipped, 3 is being skipped. So I know 5th is being skipped as well. So if I want to find the error here, then it's going to be f of the 6th derivative of z has to be less than or equal to 1, right? Because sine and cosine cannot be above or below 1. And so then my error has to be less than or equal. So we're going back to the Lagrange error. So if we remember that, has to be less than or equal to 1 to the 6th, because I'm doing it for the 6th term, over 6 factorial, and then times 1. And so that would be less than or equal to 1 over 6 factorial. I should have brought a calculator over here. What is that? 720? Did I do that right? 530 times 4 is 120. Yep. Okay, so then there is my LaGrange error. Has to be less than or equal to 1 over 720. So that means my approximation of 13 over 24 is within 1/720th accurate. So if we want to know what the cosine of 1 is, so actually, I'm going to go get a calculator. I'll be right back. Okay, here we go. Okay, so I'm going to quit, and I'm going to do in radian mode the cosine of 1, which is 0.54. And then if I do 13 divided by 24, I get 0.54. And then 1 divided by 720, 0.001. Yay! Okay, so these are, let me show you real quick. I guess I should be doing this right here. Okay, so the cosine of 1 was 0.54. My approximation was 13 over 24, which is 0.5416. And so my error, I'm showing that I'm within 1/1000th of that, and I am, right? If I look at the difference between those, I'm within that value of what it really is and what I approximated with 3 lousy terms. So now, if you want to know what the cosine of 1 is, you can just, if you know your expansions, you can just plug in whatever, and you can do this kind of math in your head, whereas the cosine of 1, I can't do that in my head. I don't know what that is. Okay? So that is one more practice of the LaGrange error. And hopefully that is enough to get you guys rolling on that one. And then let's do another one, but I'm going to switch to the next screen here.